Welcome to our first lecture for Stat 110 Online. We're going to cover our lectures with online videos, usually from 10 minutes to 18 to 20 minutes in length at most. And you should have the lecture notes that are on the screen printed out ahead of time. You can fill them in as we go along. Let's get started. Chapter 1 is called Where Do Data Come From? The field of statistics is applicable in every discipline. To name a few, educational research, all the sciences. The Food and Drug Administration requires the use of statistics to approve drugs based upon clinical trials. The companies have to use statistics to demonstrate that their drug is effective and to report adverse events. Statistics is used widely in advertising, in market research. When you take your buy low bonus card up to the grocery store, do you think that they just want to give you fuel perks or coupons? Probably not. They are actually collecting data every time you shop. Grocery store cards, such as the buy low bonus card, I'm not just ragging on buy low, are a way for them to collect data. You're telling them when you shop, how you shop, what you buy, how you pay for it, etc. Statistics is how your insurance rates are set and also your credit score. These are models for risk. When they give you an insurance rate, it's based upon how much risk you are offering to the company. Same with your credit score. A credit score is based upon a risk model for what is the likelihood that you're going to default on your loan. So, our first example is an example that I took from Professor Brian Habing, and I think everyone in here probably knows what RateMyProfessors.com is. Stat 110 instructors often get comments about how the practice test looks like the real exam, and therefore the class is easy because you can just take the practice test and don't have to worry about really studying for the test. Should you believe that? Here are some interesting statistics that we're going to look at from Exam 2 in an offering of Stat 110 in a recent semester. This was a face-to-face class, so N was 379, which means that 379 people took the test on this particular day. We're going to look at a couple statistics here. This output is from a statistical software package called StatCrunch, which was actually developed at the University of South Carolina from Dr. Webster West, who has since moved on. And we see that the mean or the average score on this particular test was a 78.5. Now that's a C+ according to our syllabus, which I'm sure you all want to do better than that. I want the students to do better than that as well. The median score is an 82, and we're going to learn later in Chapter 12 that the median is the score such that half the class scored below it and half the class scored above it. An 82 is a low B. Q1 is a 70 and Q3 is a 90. What does Q1 and Q3 mean? Q1 is the first quartile. That is the score in the exam range such that 1/4 scored below it. So Q1 has 1/4 of the scores below it, and then Q3 is similar. Q3 has 3/4 below it. So if 1/4 scored below a 70, that means 1/4 of the class has a D+, a D, or an F. Q3 of a 90, if 3/4 of the class is below a 90, then 1/4 is above it. So 1/4 of the class got an A on their test. So, as you can see, 1/4 of the class failed the exam, 1/4 of the class got A's, and the other half got B's and C's. So, does it sound like if the practice test is exactly like the real test, and mostly everybody comes to our reviews in that class, so they've done the practice test, does it sound like the practice test is exactly like the real exam? No. It turns out that in this particular semester, the grade range for exam 1 was really high because everyone followed our advice and did all of the homeworks ahead of time, submitted them on time, took both attempts, worked by themselves, and then asked questions when they needed to, and studied the way that we recommend. And then for exam 2, those same students kind of slacked off a little bit because they did so well on exam 1. And it turns out a lot of them used the strategy to only study the practice exam and not actually look at the other material for the course. And so the grade distribution went down. So the lesson that we learned here as Stat 110 instructors, after carefully analyzing this data, is that the practice test looks like the real test to the students who actually studied and understood the concepts rather than just trying to memorize specific questions on the concepts. All right, so as you can see, we have to dig down with our statistics to answer important questions. So we're going to look at a claim found on MedPage today, published January the 14th of 2013, and it's titled Fast Foods Tied to Allergies and Eczema in Kids. The article states that children and teens who ate fast foods multiple times a week were at an increased risk for severe asthma, rhinoconjunctivitis, and eczema. Consumption of fast foods 3 or more times a week was associated with a 39% increased risk of severe asthma and a 70% increased risk of severe eczema among teens, according to Philippa Elwood, DDN, DPH of the University of Auckland in New Zealand, and colleagues. So it goes through a couple of other points here. And so we want to ask ourselves, all right, consumption of fast foods 3 or more times a week is associated with a 39% increased risk of asthma. Does this mean that if we let our kids eat fast food 3 or more times a week, they're going to have asthma? Or that this is causing the increased risk of asthma? Well, how would they get their data here? It turns out, as you can probably imagine, we can't really recruit people and then prescribe them to feed their children fast food 3 or more times a week. An ethics panel would probably find that unethical. And so the way that we collect our data here is through what we call an observational study. An observational study gives us associations between variables. Which does not imply causation. So in an observational study where we didn't prescribe treatments, we have to ask ourselves, what is the root cause of this association? Here you can imagine there's all sorts of other factors that might be tied into why these children are developing asthma. Other environmental factors. Our next article is another MedPage Today claim, run for your life, right? Now it sounds like we're making a good claim here. Question, do you run for your life? Right, with an exclamation point. So can we believe this claim? If we take a look at the article, you will see that, there we go. It claims running for even 5 to 10 minutes a day, once or twice a week, or at slow speeds is associated with substantial mortality benefits over 15 years. Runners overall had 30 to 45% lower adjusted risks of all-cause and cardiovascular disease mortality, respectively, over that period, and had 3 years longer life expectancy compared with non-runners. So again, how did we collect the data here? You can imagine, before I even read down through, that we probably didn't prescribe runners to run for a 15-year period. Again, if we read through the article, we'll see that this is an observational study. We observed what these runners were already doing and then observed whether they had cardiovascular mortality, how long they lived, etc. So again, this is another observational study. Now, compared to the last observational study, we already know that with an observational study we can show associations which don't necessarily imply causation. But here, how are we going to get that causal link? Well, we have to account for what we call confounding variables, lurking variables, and try to tease out what the real effect is. Because there are lots of other studies on cardiovascular health and running, it's a little easier for us to accept the notion that we think running is one of the causal factors in this longer life expectancy and reduced risk of mortality. But a little easier to draw a causal link based upon previous research and expert knowledge. So how do we get this causal link? Let's take a look at our third article. 3 years of treatment with IV immunoglobulins prevented further cognitive decline in patients with Alzheimer's disease, according to a small study presented here. As measured by multiple standard instruments, the Alzheimer's Disease Assessment Scale, the Clinical Global Impression of Change Index, and the Neuropsychiatric Inventory, and others, the 4 patients who received the full 36 months of treatment at 0.4 grams per kilogram every 2 weeks showed no decline in scores, reported the researchers in this study. Here we have what's called a randomized controlled experiment. Here we prescribed certain dosages of this medication. It's not just an observational study because we prescribed the treatments, we applied the treatments. In a randomized controlled experiment, the key word here is experiment as opposed to observational study. We assigned treatments so we have a stronger link, reason to show a causal relationship. So stronger evidence for causation. However, even though this is the gold standard, having a randomized controlled experiment, we still need to make sure results are repeatable and generalizable. So if we repeated this study, would we get the same results? And also, do they apply to the whole population of Alzheimer's patients? Our last intro example is on a web page called Pew Research. And Pew Research is a really good website because they're very transparent with how they collect their data. So if you ever need to research something for a class project or whatnot, you could come to Pew Research and take a look there. Barely half of U.S. adults are married, a record low. In this article, it states that 51% of today's adults are married. So what kind of data collection did they use here? You'll see, if you explore around Pew Research a little bit, that they are a polling company, much like the well-known Gallup poll. We took a survey. So we're going to call this a sample survey because it's a sample of our population, and a survey because the individuals provided their own data. We asked them to tell us the answer. So here, 51% of the sample are married. Now, what happens with sample surveys? How are these different from a standard observational study? We didn't apply treatments. We didn't tell people to get married. We didn't tell people not to be married. It's an observational study, but it's a special type of observational study called a sample survey. So what are the differences between a sample survey and a traditional observational study? Well, new types of bias are introduced. Because people can give incorrect responses. They can lie, they can forget. Now in this one, I think people would know whether they're married or not. So I don't think they're going to forget, but they could lie. They might not want to tell their actual marital status to the person on the other end of the telephone or the computer. And they might get it wrong because of our technical definition of what's married, separated, etc. So now, we've shown some examples of different ways to collect data and our widespread application of statistics. So now we're going to get into the meat of the lecture. So we're going to learn some definitions. Statistics is the science or art of data. Individuals are the objects described by a set of data. Individuals can be people, but they may also be animals or things. The way that you sometimes want to identify individuals, because it's not always cut and dry as it sounds, is you want to remember that when we have treatments, we're applying the treatments to the individuals. The individuals are kind of what we're getting our data, our observations from. A variable is any characteristic of an individual. A variable can take different values for different individuals. We're going to have different types of variables, which we're going to discuss in detail in later chapters, and we'll introduce the notion of different types of variables in just a moment. The actual measurements recorded for individuals are called data. Note that data is the plural form of the word, and the singular version of data is datum. Datum is a single data point. Now most people, when they're discussing a single data point, call it a single data point or a single observation. However, you're going to see the word datum at some point in your life, and I wanted you to know what it was. So datum is just another way to say a single data point in a data set. Example 1. We've got a table with some names, major points, and grade. What are the individuals here? We're making observations on people or students. We can tell that they're students because of what we're collecting information on. What are the variables? What are the characteristics of the individuals that we're recording here? We've got their major, their points, and their grades. So we've got 3 variables that we collected in this example. Example 2, we've got another table with some data in it. We've got the make, type of vehicle, type of transmission, number of cylinders, city miles per gallon, and highway miles per gallon. So what are the individuals here? What are we making our observations on? This time, it's vehicles. It's not people, it's things. And the variables, I won't waste a lot of time writing them all down. You can see what all we collected variables on. The make, the vehicle type, the transmission type, the number of cylinders, city miles per gallon, and the highway miles per gallon. So now you're done watching this portion of a lecture. You're going to click Next at the very bottom of your Canvas screen, and it's going to take you to a Check Your Knowledge quiz. Try the Check Your Knowledge quiz. It might be tricky at first. These are always a little more difficult when you have to think of them on your own. You have unlimited tries on the Check Your Knowledge quizzes, and the points that you earn from them are bonus onto your homework. They counteract any lost homework points. Good luck.